We're going to graph this function y equals 2 secant of x over 3, and we're going to use what we understand about zeros, reciprocals, infinities, and the cosine graph to get this thing to work out. And so the first thing I want to mention is if we're trying to graph y equals 2 secant of x over 3, we're going to use the fact that the reciprocal of secant is cosine, and we're going to go ahead and graph y equals 2 cosine of x over 3. We're not going to graph it. I misspoke. But we're going to think about when this is 0, and when this is maxed out, and when this is minned out. So in this video, if you need a review of how to graph something like this, go ahead and watch this video. But if you're confident you know how to graph this, then you can go ahead to the next video right off the bat or skip to the end of this one. I just want a refresher of how to handle this for anybody who just needs to hear me talk through it another time. The standard cosine function, we know whatever cosine is doing at 0, it does a bunch of stuff and starts to repeat after one full rotation. It repeats at 2 pi. So to graph this cosine of x over 3, I'm going to start by trying to figure out when is cosine of x over 3, like when am I taking the cosine of 0, and when am I taking the cosine of 2 pi. That's what I want to figure out. I'll be taking the cosine of 0 whenever x over 3 equals 0. And I'll be taking the cosine of 2 pi whenever x over 3 equals 2 pi. Now, doing some pretty straightforward algebra, we know that this happens when x equals 0. We know that this happens when x equals 6 pi. So this function starts in the same place as the normal one. It starts at 0, but doesn't start to repeat itself all the way until we get to 6 pi. I'm going to go ahead and mark these marks on my x-axis. And now for good measure, I'll put one on the other side. And this, I'm not 100% to scale, as per usual. And we just need to figure out now, break this into 4 equal pieces. Break it into quadrants, because at each quadrant, cosine is either its biggest value of 1, its smallest value of -1, or it's 0. And those are the points that we tend to care about. Where is the function its highest? Where is its lowest? When is it 0? And that happens for cosine and sine in 4 equal intervals over the period. So halfway between 0 and 6 is going to be 3 pi. Halfway between 0 and 3 pi is 3 pi over 2. And then if I think about all these numbers as being over 2, I could think of this as being 6 pi over 2. I could think of this as being 12 pi over 2. Then it's pretty obvious that this middle one is going from 0 to 3 pi over 2, 6 pi over 2, 0, 3, 6. This will be 9 pi over 2. And of course I want those same values on the other side. And I want them to look more uniform than they currently look. Then, if it's a cosine function, and it's a 2 cosine function, I know that I've got these lines here at 2 and -2. Pretend like that's at -2. Now the next thing is, for a cosine, we know it starts at its maximum value. In this case, that maximum value will be 2 times 1. So it starts up here at 2, then it's 0, then it's down here at -1, then it's 0, back up here, and this side does the same pattern. So now I'm not going to connect those dots right now. I'm going to stop, but those are the key points I would have for cosine. So now how do we use those key points to help us deal with the reciprocal function of secant? I'm going to handle that in the very next video. So check it out, and I hope it is helpful.